is Clifford. This is going to be a talk on engineering efficiency. That's my full name. And I'm a data engineer. I should explain what data engineering is, but the whole talk is designed to make you understand what it is. So, one of my goals is that when we are done, you'll be able to tell me what data engineering is. Okay? Great. I'll start this way. Imagine a small startup, two young boys, university students perhaps, always hungry, not enough time to prepare a meal, so they are always jumping from one room to the other, perching or like, when we're in university, one of our halls, there are some people that were always cooking. So when you pass by, you smell some food, you enter the room with a bowl, you can eat with them. Great. So these guys are like, they're always jumping from them to them. But that hunger birthed a desire to build a food delivery app, which we are calling Gesture. All right. Yeah. So we are going to talk about data engineering by looking at how a company grows from startup stage to when they are big, like what's the biggest food delivery app now? Maybe Bolt Foods. Glovo is out of the system, but yeah. Okay, great. So, I mean, they started like very well. App is looking good, UI is on point. People have started like ordering on the app. There are vendors that have been rolled onto the app, and a few orders per week. So things are looking great. There's happy customers, and these startup guys who, from one day of hunger, and now they are able to feed not only themselves but other university students. These are looking promising, and but something happened, as it normally does. Word of mouth and maybe social media. Before long, their little app that was just feeding maybe a small university community. Now thousands of people want to use it because, oh Charlie, we've heard that the food prices are cheap there. So now there's a problem. Data is now everywhere, in Excel sheets, in WhatsApp messages, in email reports, and all of that. But none of it was really connected. And so because of that, they had a problem of size. A simple question like, how much sales did we make this week? Can become very complicated to answer because data is scattered everywhere, right? Very good. And the understood this happens a lot in a lot of organizations. You'll be surprised how often this happens, even in very, very large organizations. This problem exists. So, yeah. But this problem has a solution, and this is where data engineering comes in. So, what are we going to do today? Two things. We'll explore how data engineering can help anybody, any company size, but more importantly, I want to make you all data engineers. And if I'm not successful, at least I want to make you think like one. Very good. Okay, so let's begin. So early days, like I mentioned, things are going very great. Founders are on fire. New restaurants are joining every week. Just Shop is now getting famous. People are using it all the time. So spreadsheet, like I mentioned, data is everywhere. Maybe there's a few Python script. There's the app database that sometimes they can write some small SQL and then pull some data from there and then use it. And maybe they can get some reports. But you see, it's a lot of things to do. So how does this look like typically? I don't know if you can see my little diagram, but it's just a cycle of reporting. Oh, I need some data, so what do? Let's call the analyst. Wherever he gets the data from, we don't care. I need my report on Monday morning, 8 a.m. as an email. So analyst will go and do his magic, gets data from everywhere. Maybe you download this data from the app database. You get payments data from Excel, an Excel dump or CSVs, and then you combine everything magically into a single report and then produce it. Those days, analyst's job is very tough. So from that Friday to Monday, he's not sleeping because he has to get his reports done. When it's done, then the next thing happens and it goes on and on. But one time operations of just shop, as it normally happens for startups, they thought it wise to do promotions. How many of you like promotions? Like, let's say, I think sometimes when you open Post Food Hub, they'll say there's a discount of 10%, like 10% off every meal, or like free deliveries. We like that, right? So promotions always mean that more data will come in, or effectively, more people will order, right? So that means more data. I mean, and that's where it starts to get interesting, because when there's more data, it means that we have more problems to handle. And that analyst that was just doing this cycle from Friday evening to Monday now has a lot more things to do. Are we following the story? Very good. So this is how, as the first step of what a data engineer can do, this is what he can do. Now, you see that we are moving from the data down. I don't know if you can see the diagram well. So there's a data down, there's an Excel report, and then they send an email. So we move from that and we have something we call ETL. ETL is a magic word in the space of data. The E stands for extract, the T stands for transform, and the L stands for load. Very, very simple. In your first few years as a data engineer, those three words will be very, very common to you. You start hearing pipelines, ETLs. But what exactly does it mean? It means that we take the data from somewhere. We do something to the data, we clean it, we change the shape, or we change something about it, and then we dump it somewhere. Now the final destination of the data is now in a state where it can be used for a lot of things, like building a dashboard, having an email report. Do you get the idea? So this, as a company at that size, where there's not like a huge mass of data, it's just data in specific places scattered all across, the first step is to just have an ETL. And it's very, very simple. You don't need a lot of tools. Python is enough. Python and SQL. Get your data in one place. You have it. And Python, as long as you have Python, it means you can automate some process. So you get the data, you can automate the process of collecting the data from various data sources, then you do the transformation as well, and then you store it. In one giant Excel is enough. You are not too big, so you don't need to worry about it. Alright? So that's the first step. Now what this does is, because something trust, and it's very, very important. A lot of times, I think the most recent Shatawale's concept was a huge reminder of why numbers are important. After the concept, they are now arguing over what was the actual count of the people that attended. Can you believe that? Some will be claiming, but you see, numbers are very, very important. So if you have a system that is able to give you the right numbers, you are building trust. It means your bosses can trust you. Do you get it? So if you say that, oh, there are 5 sales, and then they go and check, and there was actually 5 sales, they can trust you when you bring another report. That tells them that there are 10 sales, but 5 went bad. They can trust you now. Do you get it? So that's the first step of every data engineer, to build trust with your data. So when you automate that first process with simple ETL, you're able to garner that trust. Are we following? Great. But something happens. A company kept getting bigger. And that's something that usually happens all the time. And it's actually very good. When people are using your app more, it means more money is coming in, which is good. But then there's also the side of, okay, it also means more data. Now when there's more data, it means your simpler systems can no longer handle the load, right? And I'm calling this the scaling things. Now, the same automated Python script that will pull the data from the various sources, now they are taking too long to run. At first it would take like 5 minutes, but now they are taking hours, sometimes days. I remember in one of the places I work, we had a script that was pulling data for about 4 African countries across various models, so across various teams. So there was finance, there was payments, there was customer service data, there was core data, various sources. And a single pipeline was taking close to 6 hours just to run. Terrible. So things like that really happens, right? And so now they've expanded, there are lots of things, but now the reports that the analysts could do, I mean, it was tough, but you could do it from Friday to Monday. Now he's saying that he needs an entire week to do. And you can't blame him. Once again, the company will be blind because now they can't really see. They can't really see. So now when they are in their weekly meetings, if you are familiar with, and there's a question, maybe one team, revenue team will come and say, oh, today we had 150K of sales revenue last week. But marketing is insisting that no, it's not 150, it is 180. Now, finance is also claiming that no, it's not even 180, it's 160 because some numbers come from mobile money. Now, the meeting that was supposed to be about making decisions for the next phase of the business, it has now become an argument over numbers. My data is right, my data is right. So you see, they all have a version of their own data, and they're all reporting based on that. At that stage, we need something else. We need something else. Because what's happening is that there's no single source of truth. Everybody is claiming that, oh, my X is the right one, but it's not the case, right? So what we do is we move from the simple ETL, we now build out an entire data system. Now the entire data system is actually just a further complicated view of the same ETL. So don't forget ETL. So the first thing is, okay, if you can see on the extreme left of the diagram, the second diagram, on the extreme left, you see that we are moving away from ETL to that. So the first part is we are going to consolidate all our data sources. For example, we have payments data from Momo, we have core data, in case that's important. We have the vendor data as well. We have data from the database itself, all of those. We consolidate that, you build a system that consolidates that into one and pushes it to a single source. We call it a data warehouse or a data lake. It's just like a final resting place for all data that is available to the company. Now, the final resting place becomes a single source of truth. And from that single source of truth, every team will now build their reports off of that. Does that make some small sense? Very good. Very good. Alright, so at this stage, we have evolved. We are no longer, our data system is now big and robust enough to handle large chunks of data. At the same time, to handle large varieties of data. Because I'm saying big data, there are lots of ways to define it, but when we say big data, we are always looking at specific dimensions. So size, we can have a few petabytes. Where I work currently, I deal with rows. A single select star query can produce about 5 million records. A Snowflake database can produce about 5 million records. It's mind-blowing to think about. It's a very large firm in the UK, right? But so that is scale. When we talk about scale of data, that's where it can get to, right? And so you have just simple systems, but very robust. It can handle various data sources, and then all it does is collects from A, B, C everywhere, push it into a single stream, store it in the data warehouse. Now finance team can plug into the data warehouse. Now payments team can plug into the data warehouse. Now marketing team can plug into the data warehouse and find the data they need to produce their reports. And because it's all coming from a single source, we can trust it. Does that make some sense? So the conclusion for that is, you see, it's not really about more data, it's organized data. And it's very interesting because one of the popular use cases for data now is machine learning, AI stuff, right? And one of the serious limitations of machine learning AI is data. And people always argue more data. It's not really more data, it's quality data. And you can't get quality data if your data generation process is not organized. You have a lot of issues. So to get to an efficient point, you need organized data. And such a simple system such as this can help you push the data in a right pipeline so that you can trust it, so that it can be organized, and so that it can become a single version of truth. Alright. So now this is the final stage. The company has blown. It's not just in Accra, it's not just in Ho. It's now expanding to West Africa. I'm seeing a recent company now that's doing that, Chodek. They just came from Nigeria and they're all over the place now in Ghana. So the company is growing. Now their data, as you can imagine, is also expanding. I mean, food is a very, how do I put it? It's a very internal need. Essential. It never stops. The average human can, I'll just say, it is said that we are supposed to eat 3 times a day. You and I know that that's not really the case. It can be more or less, right? But like if you think about it, at least every day somebody eats. So imagine that you have a service that is able to supply food for everybody, and efficient, it means that more people will get it right. So I'm just trying to make you understand what scale will look like. So now they are no longer just in Ghana, they're in Nigeria, they are everywhere. Now there's a need for a new system because the system that we built initially will not be able to handle that load anymore. Now, this is where, now the other side, there are thousands per day, not per week, per day. Thousands of orders per day. And now we are servicing vendors from all over to the West African continent, the West African part of Africa, right? We are servicing vendors from all over. And everybody is using the same application. Everybody is producing a lot of data, right? So, at that point, you've been able to build that central warehouse I was referring to, that single source of truth. And you can collect data from everywhere. The moment you collect the data now, the various teams can plug in their reporting reporting systems. It could be dashboards, it could be automation for email reporting, all of that. And they are like, you set up some alerting and monitoring on the pipelines. Now, what happens is that now we are thinking about new problems. Now data is coming in very quickly. Sometimes, I mean, like, how often will you make an order? Maybe 15 minutes, so we can see that within an hour, you can have like 500 orders coming through. Now that means the data is now growing. So your system should be able to handle various versions of this data load. Now, it's the same diagram as before, but this time we added a few things. So you can see here, sometimes you think about your data in terms of streams. It's going faster, so you want to report real time. Like you want your vendors to see the moment somebody orders. You want the payment to record the moment somebody orders. All of those things now you're handling real-time systems and you're handling batch systems as well. Now you set up monitoring tools to see what is happening to the actual system. Alright, so at that point we are talking decision pipelines. Alright, so the sad truth about all of this is if you do your job well as a data engineer, nobody will know. Nobody will see you. That's one of the sad truths. Because I don't know, I'm not sure how many people have heard of data engineering before now, but it's not really something you hear a lot of times because you always hear the other side of it. You hear the machine learning guys, you hear the AI guys, you hear the stuff. But the people that actually do the plumbing work, for the others to do the magic, they are the data engineers. But that's the beauty of it. When you do your job well as an engineer, as a data engineer, nobody will know. But they will get the impact in the data, the quality of data that they receive. Alright, so let's bring it home. Can we engineer efficiency with data? I think so. We can. By building resilient data systems. And I think that everyone here, you can start thinking like that. You can help your organization by thinking like a data engineer or become one.